Hello, everybody, and thank you for joining me again. We're looking at more of our Ontario Senior Math paper from the year 1968, and we are up to question number 11. Three successive transformations, A, B, and C, are applied to points in the Cartesian plane. A takes xy to x minus y, x plus 2y. B takes xy to minus 2x, y minus 3x. And C takes a point xy to 2y plus x, and then the new y coordinate is negative x minus 5y. Looks like we've got three parts, and if just a quick glance at these three parts, it looks like we're doing A, B, and C all together. So first thing is probably figure out what A, B, followed by B, followed by C actually does to the plane. But let's read these questions all together, make sure I'm really understanding what we're talking about. A, prove that the image of a straight line after ABC has been performed is still a straight line. Find the image of this circle. So the circle, it starts here and then maybe it gets flipped into a parabola and then suddenly it becomes an ellipse again and then, maybe somehow it becomes a straight line after all this process. So find the image of the circle after A, B, and C have been performed. Give your answer in this form, f of xy equals 0. So I suspect it'll probably stay as a conic section or something like that. C, determine the area of the image of the triangle formed by these points after they've been performed. So the operations just take points to points to points. So these 3 points will just move to 3 other points and we'll get a different triangle. But we want to figure out the area of that. Okay, so great way to start this off would be to say, well, what is the effect of A, B, and then C? Because they're being a little bit secretive about it. I think that's got to be our first goal. So let's say old coordinates, and then we'll make new coordinates. So if we start with xy, and we perform A, it's x minus y, x plus 2y. All right. Now let's take coordinates that are at x minus y. So where xy landed, we're now going to apply b to that point. And so here's where it's going to get a little tricky. What does b do? B takes minus 2 times whatever the current x value is. So that'll be minus 2x minus y. And then it was y minus 3x. So whatever the current y is x plus 2y, referencing the old coordinates, minus 3 times our x. So let's simplify that. 2y minus 2x. X minus 3x, that'll be minus 2x, 2y plus 3y, 5y. So that's where we're at. And now if we end up at that point, let's transform that point and see what C does to it. And then we'll see where a single point xy ends up after this whole process is done. Okay, so what does C do? Whatever the y coordinate is, double it, and then add x. So minus 4x plus 10y, and then plus 2y minus 2x. Double the y, add x, and then minus x minus 5y. So that'll be plus 10x minus 25y. So let's simplify this. Minus 4x and minus 2x, that'll be minus 6x. And then I think it was plus 12y I spied there by my little eye. Yep, 10y plus 2y. And then we've got 2x and 10x, so 12x here. Minus 2y minus 25y, that'll be minus 27y. So that's the overall sort of effect of A, B, and C on a single point. So now we know sort of what transformation we get when we do A, B, and C together. And that's, as I say, really all that matters, because in each part of this question, We're doing ABC, ABC, ABC. Okay, so I understand what happens if you do ABC. Prove that the image of a straight line after ABC have been performed is still a straight line. Okay, so what's the best way to do that? There's lots of different forms of the line, so I'm tempted to write y equals mx plus b and then transform the x's and the x's and the y's and see if they're still related by some like 3m and then b minus 2m or something like that becomes the new b. But I feel like this wouldn't earn all the marks because you're missing out on lines like this, lines where x equals. So could we use a more general form of the line? I think so. So let's say something like consider the line ax plus by minus c equals 0. And the only reason I'm doing it this way is because they got something similar in the b part that I read. So for a given a, b, and c, x and y satisfy this expression. Well, then any x and y on this line are taken to these new coordinates. And so I'm going to have to try and find a way to use a, b, and c, because the only thing I know about x, y is it must satisfy this equation. So I'm going to call it x, y, capital X, capital Y in there. Now, the only thing I know is x and y and how they're related. So it would be really nice if I could use these two in a nice linear way to get back to x. So what could we do? Well, if I want x, I don't want to have any y's. So let's see, 12 as a factor of 3, 27 as a factor. Let's do 9x, and we need a factor of 4, so 4y. And that'll be minus 54x, 108y, the old y, and 48x, and 108y. And so 9x plus 4y will just be minus 6 of the little x. So x is 9 of the new x plus the 4 of the new y divided by negative 6. So now I've got my original x, and I got it using only sort of linear expressions. We should be able to do the same thing with y. Actually, this will be really easy. 2x and a y because we started with 12. So minus 12x plus 24y, and then 12x minus 27y. And so 2x plus y is negative 3y. So if I want the original y back, again, we can use nice linear expressions. Nothing's being squared. The x's and y's aren't being multiplied. There's no multiplication to speak of, so we get the old y back that way. What do we know about the old x and y? We know that ax plus by minus c is equal to 0, and this looks like a line. So if we do a, and if my notepad will work with me, the red's fine. Why did the black fail on me there? All right, there we go. So we should get 9x plus 4y over negative 6 plus b. And then we're going to expand this out and regroup the x's and the y's together. 2x plus y over negative 3 minus c is 0. So we'll get minus 9ax over 6, just to get the minus sign out from the bottom, plus, or minus 2bx over 3. So there's my x's. And then we'll get minus 4ay over 6 minus by over 3 minus c is 0. Let's take out the x's and get a common denominator. So minus 9a minus 4b over 6x minus 4a minus 2b over 6y minus c is 0, and this is a line. This is a brand new line. And all we'd have to do is say which is a line. So our transformation takes this nice general line to the new line minus 9a minus 4b over 6x plus minus 2a minus b over 2 y minus c equals 0. And just cleaning up. Oops. Oh, great, it's doing that again. Oh, there's that. Looks like we jumped. So all I'm doing is dividing by 2. Oh, so that should be a 3 on the bottom there. Okay, so just got to change that. Oh, why is the software failing? I'm going to have to restart after this video, aren't I? I'll just do it by hand. My kingdom for the ability to write a 3. There it is. Okay. Sometimes these things are buggy. Okay, but we just get a sort of a new line there. Okay. But that's all you need. That's all you need to describe a line. Just put it again in general form. Okay. That's the first one. We've got took a line, always take a line to another line. Fantastic. Now, for the second one, I think we're told we start with this circle, x squared plus y squared equals 1, and I want to know what is the image? What does it now look like? Well, fortunately, we learned xy gets transformed to, what was it? We're going to have to go back a bit, aren't we? Minus 6x plus 12y and 12x minus 27y. And I called those x's and y's. We also just saw, not a moment ago, so we'll say we saw in A, 9x plus 4y over minus 6 is x, and 2x plus y over minus 3 is y. Let's go double check those. Yep. So what do we know about x and y? They're on this circle. That's it. And I'll bring the 1 over here just so they've got the sort of expression they want. Over minus 6 over minus 3, 9 capital X plus 4y, and 2 capital X plus y Those are our expressions. So I think we should probably clean this up a little bit more. So I'll say 80, 81 capital X squared plus 72xy plus 16y squared all over 36 plus 4x squared plus 4xy plus y squared all over 9 minus 1. Multiply everything by 36. That gets rid of this 9 at the cost of a 16 up here. 16 and a 4. And that 1 turns into a 36. And now we can just group these. So 97x squared plus 88xy plus 20y squared minus 36 is equal to 0. And I think that's a nice, neat expression. Whether or not you can actually turn that into a circle, I'm not entirely sure. I don't think so. I think it's just sort of a generic conic section. But I'm happy with this expression because, well, it satisfies what they asked for. I mean, technically, so did this one up here, but I thought I'd clean it up a little nicer, a little neater there. Okay, so that's C part, or B part, on to C part now. Determine the area of the image of this triangle. So 0, 0, 0, 1, 1, 0. This won't be bad at all. Hoping. So 0, 0 gets sent to 0, 0. 1, 0, you just need to pay attention to the x's. It's minus 6 and 12. And 0, 1, the only thing that's non-zero is the y value, so that'll be 12y and minus 27y. So we get a new triangle. Well, actually, is there a bit more to say? Because how do I know that this whole triangle expression, I mean, these points go here, but how do I know it doesn't turn into some sort of weird loopy figure like this, and now the area is out here? But we saw in A part that these lines will just get mapped to other lines. The bounds of the triangle, which are lines, get sent to other lines. So I'm confident that it's triangles are sent to triangles. Okay. So, okay, so now I just need to figure out the area of this triangle. So 0, 0, minus 6, 12. Ooh, I'm going to need this up a little bit higher. 0, 0, minus 6, 12, let's say. And then 12 minus 27. So that looks like a very thin, very narrow triangle. How best to find the area? Now, there are formulas for the area in terms of your coordinates, and that might be fair game. I don't know exactly what was taught back then. Question for me is, can I figure out what that is off the top of my head? Should be able to do something with vectors. I know vectors are taught nowadays. Were they taught back then? So I'm trying to stay true to the original sort of concept here. I suppose we could figure out what this point here is, and then I've got a triangle of height 12 and whatever this length is, and then a triangle of height 27 and whatever this length is. So yeah, let's actually figure that out. So this line here has a slope of negative 27 minus 12 over 12 minus negative 6. So that would be negative 39 over 18, divided by 3, so negative 13 over 6. Okay, so that line must be y equals negative 13 over 6, x plus some b. Actually, I'm more interested in the a value, the x-intercept. Although I suppose we could do the triangle like this and then have a height of 6. Yeah, we'll just find the b value. So I know, for example, negative 6, 12 is on here. So 12 is negative 13 over 6, negative 6 plus b. 6's cancel out, minus signs cancel out. So b has got to be negative 1. So I actually drew my triangle a little wrong. They should pass under. Okay, but it's minus 1 here, this intercept here. So for this triangle here, it's 1 and then a height of 6. So the area of this triangle is 1/2 1 times 6, or 3. Very small triangle. And then over here, it's a base of 1, and then our height, such as it is you go over by 12. So 1/2 1 by 12. So this triangle over here has an area of 6. So in total, the area is 9. And there we go. A nice little area of 9. So an interesting little transformation question. I don't know whether or not there might have been a faster way. Maybe if you knew the formula for the area of a triangle in terms of coordinates. But I'd say we didn't do too bad, and that wasn't a bad line and its b value to work out. So kind of nice. I'm more interested to see whether or not this conic actually is a circle or an ellipse or something like that. I'm not sure exactly what it is. Might even be a parabola. If you want to figure it out and let me know down below, I'm more than happy to read it and revisit it and see if I agree with you. But there we go. That's question number 11. So let's make some room for question number 12, and that's what we're going to look at next video. Thanks for watching.